Okay, so we're learning the square root method today, and this is the next of the 6 or 7, I don't even know, methods that we're going to learn. And when you get done learning this one, you're going to be like, why didn't you teach us this sooner? And then when you get done with this one, you're going to be like, why didn't you teach us this, period? Okay, so I'm just going to tell you, sorry. You are required to know a variety of different methods, and you're required to know how to factor. It specifically says that you have to be able to find solutions by factoring. So we have to teach you how to factor. This is another method. You have to be rock solid on this method today because the method we're learning tomorrow, it's kind of an extension of the square root method, but you have to be like really solid on the square root method for it. So we're going to talk about some prerequisites, so some things that you got to accept as a given. So let's go up here in this top corner here and let's write some stuff down. What is this little box here? It's really annoying. We'll just move you there. Okay, so first of all, every square root has 2 solutions. Every square root has 2 solutions, positive and negative. Okay? Every square root has 2 solutions, a positive and a negative. Okay, every square root has always had 2 solutions, but we've never really cared. We've never had to talk to you about the negative solution because all the times that you've done squares and square roots in the past, you've been dealing with like area of a square and you're trying to find the side length. Well, are you going to have a negative side length of a square? Doesn't even make sense. So we've never needed to deal with the negative square root because up until now, you've been dealing with real-world situations, and real-world situations are positive. Well, now that we're dealing with equations, we're seeing all kinds of stuff we have to think about. We have to think about domain and range and like the possibility that x could be literally anything, all real numbers. It could be a square root, a decimal, a fraction. So there's all kinds of things we're having to like grapple with, all kinds of like deep realities of the soul that we're having to wrestle, okay? So, in this case, we're having to actually acknowledge the negative square root. Okay, so let's talk about what that means. So if I look at the square root of 9, a square root is what number times itself equals 9, okay? There are 2 ways that I can get 9 by multiplying. I can do 3 times itself, which gives me 9, or I can do negative 3 times itself to get 9, right? Because remember, if the signs are the same, the answer is positive. So technically, there are 2 possible answers for this. So when I look at the square root of 9, square root of 9 is 3 and negative 3. Another way you might see that written is plus or minus 3. Well, it's plus and minus, but and you see it on you're going to start seeing it on your formula chart. It looks like that. It's an actual symbol. It's an actual math symbol, plus and minus. So you're going to see that on your formula chart. All right, so both of these are ways that you might see that answer. So you have to be kind of prepared for either one. What questions do you have about this, about the square root having 2 solutions? Yes, ma'am?
How come when you put in a calculator, it just gives you the positive answer?
Because it does. The answer is this is a function machine. I mean, it's only going to give you, because it's not going to branch. It's like you're saying, okay, here's why. Because, I know, my battery is low, you're very upset. That's a good question. So the question, just in case you didn't hear, was how come when you put it in the calculator it only gives you the positive root? Well, if I put y equals, okay, here I put square root of x, right? And I look at the graph, it's only graphing positive numbers. Because when it starts going negative, when I get down here, it's going to give me negative square roots, and negative square roots are imaginary numbers. So this is a function machine, and it can't give me a negative square root because a negative square root is illegal. It's a non-real answer. So if I was doing complex numbers, if I had my calculator set up for complex numbers, instead of having it set up to real, if I had it set up to complex, then it could give me those answers. But that's not how I have it set up. So it can't do that. So it can only give me the positive root because this is a function machine. It's not going to give me anything that's not functional. If I want to see both roots, I have to do, well, I have to do that. And then it'll give me the bottom half of the curve. Okay? So it's because our calculator is a function machine, and it's not going to give us non-functional things. Does that make sense? Okay. So, all that to say, let's talk about the other kind of like given, the other kind of like thing we have to agree to. Okay? We solve operations. Sorry, we solve equations with opposite operations. Okay, now this means a couple of things. The first thing it means is that we're going to think about what's opposite of what. Basically what this means is reverse Pemdas. Okay, so what we do is we do Pemdas backwards. Okay, so let's talk about what the opposite operations are first of all. What's the opposite of plus? Minus. What's the opposite of multiply?
Divide.
Well, the opposite of x squared is square root. So when we do order of operations, we're going to do parentheses, exponents, multiply, divide, and add, subtract. But we're going to work from bottom to top. And normally with PEMDAS, we start on the inside and we work outside. Now we're going to work from the outside in. Okay? And this is actually how we solve every equation. Okay? So that means if I want to add or subtract, like if I have an adding and subtracting, I'm going to do the opposite of adding and subtracting, which is adding or subtracting, subtracting or adding. If I see a multiplication, I'm going to divide to get rid of it. If I see an exponent, I'm going to take the square root. And parentheses, whatever's in the parentheses, instead of doing that first, I'm going to get to that last. Does this kind of make sense? Okay? So this is going to come into play when we get down to some of these examples down here, because I've had a lot of people kind of struggling with this today, so I really wanted to kind of hit on this. What questions do you have about this? Okay, let's just write this one down, though. Opposite of x squared is square root of x squared. Okay, so the opposite of squaring something is the square root. Okay, so we're going to reverse PEMDAS, and the operation we haven't touched yet is square root as the opposite of squaring something. Make sense? Okay, so let's talk about this practically now. Now that we've kind of said some stuff, let's actually talk about what this is going to look like. Now, I want to show you something because I think it's important for you to kind of see what's what, okay? This first problem on your paper, this is the work that we would have done for this problem on yesterday's test, okay? We would have, because all we had yesterday was factoring as a method to solve. Factoring, graphing, and tables. So maybe you put this in your calculator and you look for 81. Maybe you decided to factor it. And when you factored it, you'd have to get it set equal to 0. Hopefully you recognize this was dots. If you didn't, you'd have to make a box and do that. Okay? X plus 9, x minus 9 equals 0. You set each of them equal to 0, and you solve. And you get to x minus 9, x equals negative 9, positive 9. Does this track with what we've done so far? Okay, so the method that we're going to do today is a little bit different. We're going to use this reverse PEMDAS to solve. Now, I'm going to write it down just so that you see what I'm talking about. Okay, so when I look at this, I'm always looking at the x side, because remember, what is the solution to an equation? What's the solution to an equation? It is the x. The solution to the equation is the x, which is why I was so surprised on yesterday's test how many people told me that the solution was the y-intercept. Because the solution is x. When I solve something, I'm trying to find x. I'm trying to find the input variable. Okay? So a lot of people were telling me that the y-intercept was a solution. But the x is my solution. I'm looking for x's. Okay, so I'm trying to get x by itself. Do I need to add or subtract anything to get x by itself? Because remember, I'm doing reverse PEMDAS. Do I need to add or subtract anything? The x squared is by itself, right? So there's nothing to add or subtract. Is there a number in front of it or a fraction in front of it? So there's nothing to multiply or divide. Do I have an exponent? So how am I going to undo that? Square root. So to get rid of that exponent, I'm going to take the square root. If I do it to one side, I got to do it to both sides. Now, this is the thing. I don't put plus minus on both sides. I only put plus minus on the number side. Okay? What's the square root of 81? If you need to, remember, in your calculator, you do second. I hear you. I know the battery's low. Let it go. You do second x squared. You put the number in the parenthesis inside, and you hit enter, and you get 9. Is 9 my answer? What's my answer? Plus or minus 9. Now, I want you to also write it x equals 9 and x equals negative 9. I want you to write it both ways because, remember there was a worksheet we did a while back, and it was like solving equations, and there was, well, there was that one. Yeah, it might have been the minions, but there was one where like, there was a problem on a test we did recently where it was like the answer was 15A, and there was an A on the bottom, and y'all all did 15 over A because you freaked out because it looked weird. Does this sound familiar? And like, and remember when we were doing that work, I was like, y'all need to write it like this because this is the way you're not familiar with seeing, and y'all didn't do that, and then you got to the question on the test and you didn't know what to do. Remember that? I'm telling you I need you to write it like this because I don't want you to freak out if you see it like that or freak out if you don't see it like that. I want you to write it all the ways you might see it so that you're familiar with not only what you might see, but what to do if you don't see the thing you're looking for. Okay? So, we went from all of that work down to this, and we got the same answer. A lot of people, there was a question like this on the test yesterday. You just gave me the positive root. So you lost 5 points. Because it was wrong. Because you tried to do the square root method, but you don't know how. Now you can do this method. Okay? What questions can I answer about this example? Okay, so let's talk for a second about this. I want to talk about something. Let's pretend, so let's look at this example back up here at the top. Let's say I want to do negative 3 squared. Put negative 3 squared in your calculator. I want to square negative 3. Put it in your calculator. You can. I want to, not square root, I want to square negative 3. How do I square negative 3? Did the batteries fall out? Or are they backwards? It's possible. So, did you do this? Or did you do that? Because they're two different answers. This matters. These are two completely different problems. Because remember, order of operations. So let's clear this one out. Well, let's just clear all this out. Negative 3 squared. When you do that, this is what your calculator sees. Negative 3 squared. So your calculator says, okay, I got to do the exponent first, so I'm going to square the 3, and then I'm going to take the opposite. When you do this, your calculator says, I'm going to take negative 3 times negative 3. Which one of those am I looking for? I'm looking for this one. We have to be very careful. Your calculator is going to strictly use PEMDAS. So it's going to, if you put the wrong one in, you're going to get the wrong answer out. You know what I mean? The wrong right answer out. It's going to give you back, negative 9. Because that's what you told it to do. You have to be very careful when you're squaring a number. Make sure you put it in parentheses, especially if it's negative. And if you think you're going to forget, put everything in parentheses when you square it. Okay? The reason I say this is because, what if this had been square root of negative 81? Okay, let me give you another example. Okay, what if I had this? What is this? What is square root of 81?
9.
What is it? It's 9 and negative 9. Y'all got to start, just hammer it into your head. It's both. What about this? What do you think that is? It's just the negative root. So if there's a sign in front of it, they just want that one. If there's no sign, you got to give them both. If there's a sign in front of it, they just want that one. Okay? What about that one? What do y'all think that one is? You can't solve it. Your calculator can't solve it. So let's talk about what that put it in your calculator and let's see what it does. We're gonna jump down to this problem right down here. X squared equals negative 36. Let's jump down to this one. Okay. Y'all, does everybody know how to put the square root in? You do second and then the x squared button because the square root sign is above it. And then we put negative 81 inside. Now my calculator gives us a little bit more information, but your calculator, so a lot of y'all say, Miss, it says error. It says more than error. Did anybody get error syntax? Okay, error syntax, 95 times out of 100 means you did this. Can you see the difference? Yeah. That's the minus sign and that's the negative sign. So when you do that, you're going to get error syntax. So basically, usually, most of the time with what we do, that means you put a minus instead of a negative. Okay? But this, though, this error is telling you something. So every time you see an error, it means something. It says non-real answer. So I want you guys to, I want you to write that down. I want you to write down error, non-real answer, okay? Because that error, when you see that, and later on we're going to be doing this thing called the quadratic formula, and you're going to put a whole bunch of stuff in this formula and put it in the calculator and like jump out the way. If you get error, non-real answer, the first thing you're going to do is check and make sure you didn't put something in wrong. And then the second thing you're going to do is say, oh, there must be no real solution. Okay? So this means no real solution. Now there's a solution, but again, you don't have the math for it yet. You're going to start to get that math in Algebra 2, and then I believe you'll get more of that math in calculus, maybe pre-cal, I'm not sure. But I know you're going to start some complex number system stuff in Algebra 2. Okay? So when you see error, non-real answer, check to make sure you put it in the calculator right, and then if you did, it's no real solution. Okay? So far, so good? So are we okay with these first two examples? Are we okay with these two? Great. Let's go to this one in the middle here. 3x squared minus 10 equals 5. This is where our backwards Pemdas is really going to start to come into play. Okay? So again, and this is how we solve every equation. So if there's an equation you're working on and you're like, I don't know what to do, backwards Pemdas is where you start. And we're going to go from the outside in. So let's look at this. I'm going to start by looking for adding and subtracting. Now if you look, just look over here. You see how this one has adding and subtracting? It's inside parentheses though. So I'm not ready for that yet because parentheses are at the top. That's the last thing I'm going to do. So even though I saw this x minus 2, I don't care about that yet. I'm not ready for that yet. I'm looking on the outside. I start outside and I move towards the inside. Okay, so do I see any add on the side? I'm always looking on the side with the x because my goal is to find the solution, which is what is x? Solution is x. Yeah, it's about to get real cringy up in here because I'm planning some kind of TikTok situation for star review. And there's going to be songs. There might be dances. I'm going to be pointing at stuff. It's going to be embarrassing. It's going to be super cringy and weird. But I'm going to get you where you are. Okay, I'm going to get you. I'm going to get how long do I have on TikTok? I'm going to figure it out, and that's what I'm going to give you. Little bitty snippets, okay? So something about this backwards thing is going to be in there because we need to get this right. Okay. Anyway, all right. So what do I see here? Do I see something added or subtracted on the x side of the equation? Yes. What is it? How do I undo minus 10? Plus 10. So I'm going to add 10. Remember, what I do to one side, I do to both sides. Now I have 3x squared equals 15. So I've done the add and subtract. Next thing going up my list here is multiply, divide. Is something being multiplied on the left side? What? 3. 3 is being, x squared is being multiplied by 3. So what I do to it next, I multiplied it by 3. So to undo that, I divide by 3. X squared equals 5. Okay? All right. Okay, so now, I see exponents. I see x is squared. So all I have is one little x squared sitting there. How do I undo x squared? Square root. So I'm going to take the square root of everything, and I get x equals plus or minus square root of 5. I'm sorry that plus and minus is so tiny there. Plus and minus square root of 5. I always say plus or minus. Actually, I say plus minus. But it's plus and minus. It's both. It's not one or the other. It's both. I got to check both. I got to find both. Okay? So that's the first way I might write it. What is the next way I might write it? X equals square root of 5 and x equals negative square root of 5. I have a calculator. What do you think I might also do? I might find what square root of 5 is. I got serious with this. So I would put second square root, second x squared, and 5, and I would see what that was. And it's 2.236, so x might also be 2.24 and negative 2.24. All three of those are representations you might see. So I want you writing all three of those for now, because I want you to be prepared for anything you see. I want you practicing going through this process so that if you get to a question and you start with that, you know how to get to this. You see what I'm saying? So I want you practicing this. I want you practicing writing it, writing both, because you might see it like that. You might see it like this. You might see it like that. And there's other representations we might see. So I want you to be familiar with all of them. So far, what do we think? How do we feel about this? Are we feeling okay? What questions can I answer about this example? Because y'all seemed okay with the first two. What questions do we have about this? Does this backwards Pemdas thing help, you think? Okay. All right, let's take a look at this next one then. This x minus 2 squared equals 25. And again, I'm going to write my backwards PEMDAS because I like to be right. Y'all know that's one of my favorite things. David and Molly, chocolate. My family's around there with chocolate, Italian food, being right. Don't worry about it. I got it. Okay? So let's look first. I have PEMDAS, my backwards PEMDAS. Do I see adding and subtracting? No. Well, I see it, but it's in the parentheses phase, so I'm not ready for it yet. Do I see this being, is the squared thing being multiplied by anything? No. Do I see something squared? Yeah. So how am I going to undo that? So I'm going to take the square root of that whole side. Remember, the side with the x, I never put the plus minus on. I put it on the number side. Now, let's pause for a moment, and I want to show you something else. This is the work that you would have done to solve this problem on yesterday's test. All this work is work that we would have theoretically, we would have put it in the calculator, but this is all work that we could have done to solve this. If we did this by hand, this is the work that you would have had to do. You would have had to expand this, multiply it out, get it set equal to 0, so subtract 25 from both sides to get it set equal to 0, then factor that, then set each of those factors equal to 0, and find your solutions. Okay? Now, based on what we did over here, what do you think is my next step? So what am I going to do with the add subtract, you think? What did I do over here? So instead of x equals, I'm going to say x minus 2 equals 5. X minus 2 equals negative 5, right? Because I've got to figure out, okay, if x minus 2 could be 5 or negative 5, I've got to solve both of those things. I've got to do them both. Okay? So now I'm just solving this equation. How do I undo minus 2? Plus 2. I'm sorry, I don't know what happened there. We're going to rewrite that as negative 3 because it went a little crazy. We went from, hold on a second. from that much work down to that much work. Okay? And again, it's just a different method. So go ahead, you can ask the question now. What's the question? Why didn't you show us this first, right? That's the question. Because there are skills that you're required to know. Okay, I'm required to teach you skills, and there's lots of different ways. Remember, they can ask you lots of different, they can ask you how you're going to solve a question, so you have to be prepared to answer how you would solve that question. Okay, yes?
Can you use this method of any equation?
Kinda. You can use it for now. You can use it when I have an equation with no b, or something in vertex form. Okay. So something where I have a squared variable and a number. All right. I'm going to show you a different method tomorrow that expects you to be like rock solid on this. Yes, ma'am. Okay, we'll figure it out in a second. Okay. Let's look at this last one. Okay. So if you look at these notes, they say, they say in general the square root results in two solutions. So you're going to have, most of the time you're going to have two solutions. Now, as you've seen, I don't want you to be thinking that they're always opposites, because they might not be. In this case, they weren't opposites, but there were still two solutions. You might have no solution, and there's one circumstance where you might have no solution, and it's right here. If I have x squared equals 0, and I take the square root of both sides, I'm only going to have one solution, x equals 0, because 0 doesn't have a sign. 0 isn't positive or negative. It's just 0. So I'm not going to be able to have a plus and minus 0. That's not a thing. There's no sign on 0. So if the number under the radical ends up working out to 0, then I'm only going to have one solution, because all I can have is 0. Make sense? Okay. What other questions can I answer? Do you guys feel like you're ready to practice? Gosh, I hope so, because that's what you're about to do. All right. Let me stop this, and then we'll get going. It's going to be an awkward stop to this video. Bye.